Hello, my lovelies. It's Susanna, and today I want to show you how to solve this equation over the real numbers. We have x here and here in the exponent, so this is an exponential equation. And to solve exponential equations, we usually have to use the logarithm at some point. The question just is, when are we going to use the logarithm? First of all, let's simplify this equation a little bit because we have this fraction here. We can get rid of this fraction by multiplying by 2 here on this side and on the other side as well. Then we can cancel out the 2 here and only the numerator is left. So we have 4 to the power of x minus 2 to the power of x, and on the other side 6 times 2 equals 12. Okay, is now a good time to apply the logarithm on both sides? Well, not really, because we have a difference here on this side. So if we would apply the logarithm here on this entire side, then we have a minus here in the logarithm, and there is no rule what we can do with this logarithm then. So it's not a good time to use the logarithm now. What else can we do? We can see if there is a relationship between these numbers here. Here we have 4 to the power of x, and here 2 to the power of x. And the 2 is a part of the 4. We can write the 4 as 2 to the power of 2. This is my 4. And then we still have to raise it to the power of x, so we have to write it in parentheses and to the power of x. Then we subtract the 2 to the power of x here and the 12 on the other side. And now we have 2 to the power of x here and 2 to the power of x kind of also here. Not really yet, but we are allowed to just switch these exponents so that we have 2 to the power of x together. So we take our base, the 2, then we take this exponent first, so raise it to the power of x, and then we raise all of this to the power of 2. So you're always allowed to just switch these exponents. And then we still have our 2 to the power of x here and the 12 here. And now we have 2 to the power of x here and 2 to the power of x here as well. And why is this so wonderful now? Because we can substitute this thing that looks pretty complicated. So from now on, instead of 2 to the power of x, so instead of this green thing, we're going to replace this by, let's say, z. You can choose any letter you want. Some people use U, others a T, whatever you like. We take z here. And here we have the same thing, because this repeats itself, we have z here again. So this is our substitution. The z stands for 2 to the power of x. This is our substitution. Okay, so how does our equation look like then? Instead of this green thing, we're going to write a z. So we have z to the power of 2 here, minus, instead of this, we're going to replace it by z, and on the other side, we have the 12. This is a way easier equation than this one here. So this is what the substitution does. It makes our equation easier first. Then we're first going to solve this easier equation, and after we found the solutions, we go back to this substitution at the end then to find the solutions for our original, more complicated equation. But first, let's solve this quadratic equation now. Let's bring the 12 to the left side. So we subtract 12 here on this side and on this side here as well. Then we have z squared minus z minus 12. And on the other side, this cancels out and we get a 0. Okay, quadratic equation. We could use the quadratic formula to solve this equation, or if these numbers here, so the one in front of my z and this number here, if they are easy enough, we could try and use factorization to solve this equation. So we want to factorize the left side, so we want to write it as a product of two parentheses, and on the other side we have our 0. And because we have z squared here, we know that we have z here and z here, because z times z equals z squared. And now we have to find two numbers, a number a and a second number b. And how can we find a and b now? If we multiply these two numbers, so a times b, then we have to get this number here as a result, so negative 12. And if we add these two numbers, so a plus b, we have to get this number here as a result, so the negative 1 that I have here. Okay, let's try and find these numbers. If I multiply two numbers, I want to get negative 12 as a result. For example, 3 times negative 4 is equal to negative 12. So the first condition would be fulfilled by 3 and negative 4. But is also the second condition fulfilled? So if I add these numbers, 3 plus the negative 4, do I get negative 1 as a result? Yes, 3 minus 4 is equal to negative 1. So I found my two numbers. 3 is my first number, so instead of a, I'm going to write a 3. And instead of the b, we're going to have the negative 4. So we have plus negative 4, which is the minus 4 here then in total. How does this help us now to solve this equation? Well, we have a product here now. We have something times something is equal to 0. And this is only possible if either the first parentheses are equal to 0, so z plus 3 is equal to 0, or if the second parentheses are equal to 0, so z minus 4 is equal to 0. Let's solve these smaller equations now. To solve for z here, let's subtract 3 on both sides of the equation so that we have z left here because this cancels out. And on the other side, we get negative 3. This is our first solution for our z. And here to solve for z, let's add 4 on both sides so that we have z left here. This cancels out. And on the other side, we get a 4. This is our second solution for our z. So let's call this z1 as the first solution and z2 for the second solution. These are our solutions for this simpler equation that we had in z. But now we have to go back to our substitution here because we just found the z solutions, but actually we are interested in our x solutions for our original equation. So now we have to take these solutions that we just found and insert them here in our substitution. So let's start with our first solution. We take the negative 3 and insert it here for the z in this equation. So instead of the z, we write a negative 3, and this is equal to 2 to the power of x. And now we have to solve this equation for x. But the thing here is that we have 2 to the power of something should be equal to something that is negative. That is not possible. So we don't get any solution for our x here. Okay, But we still have a second z solution, so let's take the 4 this time. Let's insert it here for our z, and let's see if we find a solution then for our x. So instead of z, we're going to write a 4, and this is equal to 2 to the power of x. 2 to the power of what is equal to 4? Well, 2 to the power of 2. So my x has to be equal to 2. We found a solution for our x. So let's take this solution. Let's go back to the beginning. This was our original equation, and we found this solution here. I hope it helped you. If you have any questions, please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care.